Welcome to our journey through the fascinating world of matter. Everything around us, from the air we breathe to the water we drink and the ground we walk on, is made up of matter. But did you know that matter can exist in different forms called states? In this video, we'll explore the main states of matter, how they differ, and why they're so important in our everyday lives. Let's start by understanding what matter really is, and why its states matter so much to science and to us. Matter is anything that has mass and takes up space. This includes everything you can see, touch, or feel, even things you can't see like air. Matter is made up of tiny particles called atoms and molecules. These particles are always moving, but how they move and how close they are to each other depends on the state of matter they're in. Understanding matter is the first step to understanding the world around us. Traditionally, we talk about three main states of matter: solid, liquid, and gas. But there's actually a fourth state called plasma. Each state has its own unique properties and behaviors. In this video, we'll look at each state in detail, see how they differ, and discover where we can find them in our daily lives and in the universe. Let's begin with solids. Solids have a definite shape and volume. The particles in a solid are packed closely together and vibrate in place, which is why solids keep their shape. Think of an ice cube, a rock, or a wooden block. These objects don't change shape unless you force them to. Solids are all around us, providing structure and stability to the world. Solids come in many forms. Metals like iron and gold, minerals such as quartz, and everyday items like books and chairs are all solids. Even living things have solid parts like bones in our bodies. Solids can be hard or soft, heavy or light, but they all share the same basic properties. Next, let's look at liquids. Liquids have a definite volume but no definite shape. They take the shape of their container. The particles in a liquid are close together but can move past each other, allowing liquids to flow. Water, milk, and oil are common examples. Liquids are essential for life and play a big role in nature and industry. Liquids are everywhere. Think of the water in your glass, the juice you drink, or the gasoline that fuels cars. Even honey and lava are liquids, though they flow at different speeds. Liquids can be thick or thin, clear or colored, but they all share the ability to flow and take the shape of their container. Now let's talk about gases. Gases have no definite shape or volume. They expand to fill any container they're in. The particles in a gas are far apart and move quickly in all directions. Air, helium in balloons, and steam from boiling water are all gases. Gases are often invisible, but they're all around us and vital for life. Some common gases include oxygen, which we breathe, carbon dioxide, which plants use, and nitrogen, which makes up most of the air. Gases can be found in nature, in our homes, and in industry. They play a crucial role in everything from weather to breathing to cooking. Beyond solids, liquids, and gases, there's plasma, the fourth state of matter. Plasma is made of charged particles and is found in places with very high energy like stars, lightning, and neon signs. It's the most common state of matter in the universe, even though we don't see it much on Earth. Plasma is all around us even if we don't notice it. The sun and other stars are made of plasma. Lightning during a storm is plasma, and so are the glowing lights in neon signs. Plasma TVs and some scientific experiments also use plasma. It's a state of matter that's both powerful and fascinating. Let's compare the four main states of matter. Solids have a fixed shape and volume, liquids have a fixed volume but change shape, gases have neither, and plasma is made of charged particles. Each state has unique properties because of how its particles are arranged and how they move. The key difference between states of matter is how their particles are arranged. In solids, particles are tightly packed. In liquids, they're close but can move. In gases, particles are far apart and move freely. In plasma, particles are charged and move even faster. This arrangement affects how each state behaves. Matter can change from one state to another. When a solid is heated, it can melt and become a liquid. For example, ice melts into water when it gets warm. This process is called melting. It happens because heat gives the particles more energy, allowing them to move more freely. The opposite of melting is freezing. When a liquid loses heat, it becomes a solid. Water turns into ice in the freezer. Freezing happens because the particles lose energy and slow down, locking into place to form a solid. When a liquid is heated, it can become a gas. This process is called evaporation. For example, when water boils, it turns into steam. Evaporation happens when particles gain enough energy to break free from the liquid and spread out as a gas. Condensation is the process where a gas turns back into a liquid. This happens when gas loses energy and the particles come closer together. You can see condensation when water droplets form on a cold glass or when clouds form in the sky. Sometimes, a solid can change directly into a gas without becoming a liquid first. This is called sublimation. Dry ice is a great example. It turns straight from a solid into carbon dioxide gas. Sublimation is less common but very interesting. The reverse of sublimation is deposition. This is when a gas turns directly into a solid, skipping the liquid stage. Frost forming on a cold window is an example of deposition. The water vapor in the air turns straight into ice crystals. Boiling and evaporation both turn liquids into gases, but they're not the same. Boiling happens at a specific temperature and throughout the liquid, like when water boils on the stove. Evaporation can happen at any temperature, usually just at the surface. Both are important ways matter changes state. Changing states of matter always involves energy. Adding energy like heat can make particles move faster and change state. Removing energy cooling slows them down. This is why heating and cooling are so important in cooking, weather, and even in our bodies. We see all states of matter in nature. Water is a great example. It can be ice, solid, liquid water, or steam gas. The sun is plasma. Rocks, rivers, clouds, and even the air we breathe show how matter exists in different states all around us. Technology uses different states of matter in amazing ways. Refrigerators use gases and liquids to keep food cold. Plasma is used in TVs and neon lights. Solids like metals and plastics make up our devices. Understanding states of matter helps us invent and improve technology. Matter isn't just on Earth. In space, plasma makes up stars and nebulae. Gases form giant planets and solids make up asteroids and moons. The universe is full of matter in all its states, showing just how important these forms are everywhere. Scientists have discovered even more states of matter under extreme conditions. These include Bose-Einstein Condensates and Fermionic Condensates, which occur at temperatures close to absolute zero. These exotic states help scientists understand the universe at a deeper level. A Bose-Einstein condensate is a state of matter formed at temperatures near absolute zero. At this point, particles move so slowly that they start to behave as one big particle. This state was predicted by Einstein and Bose and first created in a lab in 1995. Fermionic condensates are similar to Bose-Einstein condensates but are made from different particles called fermions. These states are also created at extremely low temperatures and help scientists study quantum mechanics and the behavior of matter at its most basic level. Understanding the states of matter helps us explain everything from why ice floats to how stars shine. It's the foundation for chemistry, physics, and many technologies. Knowing how matter changes state helps us cook, build, and even explore space. In our daily lives, we encounter all states of matter. We drink liquids, walk on solids, breathe gases, and see plasma in lightning or neon lights. Understanding these states helps us appreciate the world and make better choices in everything from cooking to cleaning. Weather is a great example of states of matter in action. Rain, snow, clouds, and fog all involve water changing between solid, liquid, and gas. Understanding these changes helps meteorologists predict the weather and keep us safe. Cooking is full of state changes. Water boils to become steam, butter melts, and chocolate hardens as it cools. Chefs use their knowledge of matter to create delicious dishes and perfect textures. Next time you cook, think about the states of matter at work. Industries rely on different states of matter for manufacturing, energy, and transportation. Factories melt metals, use gases for welding, and rely on liquids for cooling and cleaning. Understanding how matter behaves helps industries run smoothly and safely. Medicine uses all states of matter. Pills and tablets are solids, syrups are liquids, and some treatments use gases. Plasma is even used in some medical technologies. Knowing how matter changes state helps doctors and scientists develop new treatments. Artists use solids, liquids, and gases in their work. Paints are liquids, sculptures are solids, and some installations use fog or smoke. Understanding how materials behave helps artists create beautiful and lasting works. Sports equipment uses different states of matter. Balls are often solid, drinks are liquid, and some sports use gases like air in soccer balls or helium in balloons. Even the weather can affect sports by changing the state of water on the field. Cars, planes, and ships all use matter in different states. Gasoline and oil are liquids, tires are solids, and engines burn gases. Understanding how matter behaves helps engineers design safer and more efficient vehicles. Energy production often involves changing the state of matter. Power plants boil water to create steam, which turns turbines. Solar panels use solid materials to capture sunlight. Understanding these processes helps us create cleaner and more efficient energy. Scientists study states of matter in laboratories to learn more about the universe. They use special equipment to cool or heat materials, create plasmas, and even make new states of matter. These experiments help us discover new materials and technologies. The environment is shaped by the states of matter. Water cycles through solid, liquid, and gas forms in nature. Pollution can affect air, gas, water, liquid, and soil solid. Understanding matter helps us protect the planet. Our bodies are made of solids, bones, liquids, blood, and gases, oxygen in our lungs. Even plasma is present in our blood. Knowing how these states work helps doctors keep us healthy and helps us understand how our bodies function. Food comes in all states of matter. Ice cream is a solid, milk is a liquid, and the bubbles in soda are gas. Cooking often changes the state of food, making it tastier and easier to eat. Understanding these changes helps us enjoy our meals even more. Cleaning uses all states of matter. Soaps and detergents are solids or liquids, water is a liquid, and some cleaners use gases. Knowing how these materials work helps us keep our homes clean and safe. Artifacts from history are often solids like pottery or tools. Some ancient techniques used liquids like dyes or paints. Even gases were used in ancient lamps. Understanding the states of matter helps archaeologists learn about the past. States of matter can be fun. Think of blowing bubbles, gas and liquid, making slime, liquid and solid, or watching fireworks, plasma. Exploring matter is not just for scientists, it's something everyone can enjoy. You've explored the amazing world of matter and its many states. From the ice in your drink to the stars in the sky, matter is everywhere and always changing. Understanding its states helps us appreciate the world, solve problems, and create new things. Keep exploring and you'll discover even more wonders of matter all around you.